Hello everyone. In this lecture, we will see how we can represent any number as unsigned number system, signed magnitude, signed 1's complement, signed 2's complement form. So first we are starting with an unsigned number system. In the unsigned number system, we represent any number with the help of its magnitude only. That means if you want to represent plus 7 and minus 7, the representation will be same. Why? Because in the unsigned number system, we represent only the magnitude. We not check whether it's a positive or a negative. That means we have to represent its magnitude only. So in the unsigned number system, we check only its magnitude. And how we can represent 7 in a binary form? We can represent as 111. Here also, as it is a negative number, then also we are checking only its magnitude, and its magnitude is 111. That means by using the unsigned number system, positive 7 and negative 7 is having the same representation. Okay, because we don't have any dedicated bit to represent whether it's a positive or a negative number. So in the unsigned number system, we represent only its magnitude. That's why either positive 7 or negative 7, if you want to represent, for example, positive 5 or negative 5, the representation will be same. It is 101, it is also 101. There is no difference between positive 5 and negative 5 in the form, in binary form. Okay. Now the second representation is the signed magnitude. So second representation is signed magnitude. So the name is also very much clear here. Signed magnitude means what? We have to represent every number with sign bit as well as its magnitude. So for example, you want to represent positive 7. So one bit, first MSB bit is dedicated for the whether the number is positive or negative. Always positive number MSB bit or sign bit will be 0. For to represent positive number, the MSB bit will be 0. To represent it's a negative number, then the MSB bit will be 1. This is the only MSB bit. Rest will be its magnitude only. For example, I will show you how we can represent positive 7 and negative 7. So it will give us clear idea. So here, for example, you want to represent plus 7. So as I told you, MSB bit will tell whether the number is positive or negative. As the number is positive, as the number is positive 7, so MSB bit will be 0, right? And rest will be its magnitude. So magnitude of 7 is 111. Understand? So this first MSB bit will tell us whether the number is positive or negative. For example, we want to represent minus 7, for example. Here, first bit, MSB bit will tell us whether the number is positive or negative. So this negative is represented by 1. So MSB bit is 1 here, and the next bits will be the magnitude. So 7 will be represented as 111. So this is the difference between positive and negative. Only the first MSB bit will be 0 if it is positive and 1 if it is negative. Same I can show you with the help of another example, that is plus 5 and minus 5. Here, as the number is positive, so the first MSB bit will be 0 and rest will be its magnitude, that is 101. Similarly, minus 5, so the first MSB bit will be the negative, is 1 because as the number is negative, and rest will be its magnitude, so 101. I think it's clear, right? Now we will see the third type of representation, that is signed 1's complement. So third type of representation is signed 1's complement. So before understanding the signed 1's complement, we should know how to find out 1's complement. Okay, so first we will see if For example, I'm taking one example like 7, okay, plus 7. So all the positive number representation will be same. For positive number, we cannot change and we cannot find the ones complement. So whatever will be the number, it will remain same. Just like here, 0 as signed ones complement will be similar to a signed magnitude number system if the number is positive. Okay, as we are taking first example, that is positive 7, that means the number is positive, and the representation will be similar to signed magnitude. So uh, positive, so MSB bit will be 0, and then magnitude, that is 101. That means there is no ones complement form of a positive number. Clear? And it is similar to sign magnitude number system. But what will happen if it is a negative 7? Right? So for the negative 7, what we have to do, first you represent in the form of sign magnitude that we have seen earlier also. As the number is negative, the most significant bit will be 1 because the number is negative, right? And then 7 will be represented in the magnitude form as 111. After this, in order to find out signed ones complement form of a negative number, you have to take ones complement. Always remember, don't take the ones complement of MSB because it's only the sign bit. It will be same in ones complement also. It will be same as 1. Whatever will be the number, it will be same in ones complement. That means you have to take the complement of magnitude, not the sign bit. So sign bit will remain same in one's complement form also. Only the magnitude will be complemented. If it is 1, then become 0. If it is 0, become 1. So as this number is 1, becomes 0. This number is 1, becomes 0. This number is 1, becomes 0. So this is the signed one's complement form of a negative 7. Once again, I am repeating, there is no ones complement form of a positive number. It is similar to sign magnitude form. If the number is negative, then first you write down in sign magnitude form. This is a sign magnitude form. And then you take the ones complement. Ones complement of its magnitude, not of a sign bit. I will take another example and that will give you a clear idea. For example, you want to represent positive 5. So for positive 5, you have to represent in the sign magnitude form. So as the number is positive, first bit will be 0 and then magnitude, that is 101. As it is a positive number, there is no separate ones complement and it is similar to sign magnitude. So this is the ones complement form of a positive 5. Signed ones complement as well as sign magnitude, both are same for positive number. Okay. But what will happen if it is a negative 5? If it is a negative 5, first we have to represent in the sign magnitude form, and that is 1 because the number is negative, and then its magnitude, that is 101. This is the sign magnitude. But if you want to find out one's complement, as I told you earlier also, the most significant bit will be same. It will not be complement. Rest, whatever will be the magnitude, it will be complemented bit by bit. So 1 becomes 0, 0 becomes 1, and 1 becomes 0. So this is the representation of -5 in one's signed one's magnitude form, signed one's complement form. Now we will see the fourth part here, that is the signed 2's complement. So this is the fourth part here, signed 2's complement form. So it is also similar to that of one's complement. That means for positive number, the 2's complement form will be similar to sign magnitude form. But for the negative number, you have to take a 2's complement, right? So I will show the same example like that is positive 7 first. So first we have to represent positive 7 in sign magnitude form. So as the number is positive 0, magnitude of 7 is 101. This is the signed magnitude form. And as this is the positive number, it is also same as of 2's complement form. Okay, so both are same here for the positive number. But if it is a negative number, that means if we are taking -7, then you first represent in the sign magnitude form. That is, as the number is negative, so 1, then magnitude of 7 is 1, 1, 1. Sorry, it's a 1, 1, positive 7. Right. Now we have to take a 2's complement as the number is negative. This is the sign magnitude representation. This is the sign magnitude representation. Now we have to represent in the 2's complement form. Right. So how we will do? As I told you, for in case of 1's complement form also, don't change MSB. Okay, because MSB represents only the sign bit. So it will be same as that of 1 only because it's a sign bit. Rest next all of the bits you have to take a 2's complement, right? So how we can take the 2's complement? First you take 1's complement and then you add 1 in the least significant bit. It will give you the 2's complement, right? So how we will find out? 1 becomes 0, 1 becomes 0, 1 becomes 0. This is 1's complement, right? This is called as 1's complement form. After that, you have to add 1 in the least significant bit. And that will give you what? 2's complement. So the 2's complement will be 1001. This is what? The -7 in case of 2's complement. I will take one more example to clarify what is the 2's complement representation. So first, I am taking for positive 5. So as the number is positive, sign magnitude representation is similar to your 2's complement representation. So it will be, as the number is positive, 0. 5 is represented as 101. This is positive 5, and this is a sign magnitude, and sign magnitude representation of any positive number is similar to that of 1's and 2's complement. So it is also similar to 2's complement, right? Now, for example, you want to represent -5. So in -5, as the number is negative, it will start with MSB 1, and then 5 in magnitude, it will be 101. This is the sign magnitude. Then we have to find out 1's complement. As I told you, for 1's complement, sign bit will not change, right? So here in 1's complement, it is 1, 0, 1, 0. Why? Because it's the 1's complement, right? So magnitude becomes complemented. Now we have to find out 2's complement. How we can find out 2's complement? Plus 1 in the least significant bit. So that will give you 2's complement. That is 1, 0, 1, 1. So 1, 0, 1, 1 is a 2's representation of -5. Clear? So in today's lecture, we have seen how we can represent any positive number and negative number with the help of unsigned number system, sign magnitude system, signed 1's complement system, and signed 2's complement system. And the point to note is what? If the number is positive, then sign magnitude system is similar to sign 1's complement system, as well as it is also similar to sign 2's complement system. Thank you.